Welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic today chosen is from chapter 11 Thermodynamics. And today is not problem solving session. This session is questionnaire session. That is 7 questions will be spread in this session, and next session we will solve the solution of this problem. Let's move to question number 1. 1 centimeter cube of water and 1 gram of mass at 100 degrees Celsius is converted into steam at same temperature under normal atmospheric pressure of 10 power 5 Pascal. The volume of steam formed equals 1671 centimeter cube. The specific latent heat of vaporization of water is 2256 joule per kilogram. The change in internal energy is dash. Option A 2423 joules. B option 2089 joules. C option 167 joules. D option 2256 joules. That is, by knowing the relationship between first law of thermodynamics, that is heat energy, internal energy and work done, you are able to find the solution of this question. Let's move to question number 2. A sample of 0.1 gram of water at 100 degrees Celsius and normal pressure of 1.013 into 10 power 5 Newton per meter square requires 54 calorie of heat energy to convert to steam at 100 degrees Celsius. If the volume of the steam produced is 167.1 cc, the change in internal energy of the sample is dash. A option 422 joules. B option 208.7 joules. C option 104.3 joules. D option 84.5 joules. By knowing the first law of thermodynamics and the relationship, you are able to find a solution for this question. Let's move to question number 3. 110 joule of heat is added to a gaseous system whose internal energy is 40 joule. Then the amount of external work done is dash. A 150 joules. B 70 joules. C 110 joules. D 40 joules. By knowing the relation between work done and internal energy, you are able to find a solution for this question. Let's move to question number 4. The PV diagram for an ideal gas in a piston cylinder assembly undergoing a thermodynamic process is shown in the figure. The process is dash. A. Adiabatic process. B. Isochoric process. C. Isobaric process. D. Isothermal process. By knowing there is a definition for adiabatic, isochoric, isobaric, isothermal. From this graph, you are able to find the solution. Let's move to question number 5. An ideal gas is compressed to half its initial volume by means of several processes. Which of the process result in the maximum work done on the gas? A. Adiabatic. B. Isobaric. C. Isochoric. D. Isothermal. Here, if you know the work done for these processes, adiabatic, isobaric, isochoric and isothermal, you are able to find the solution for this question. Let's move to question number 6. A monoatomic gas at a pressure P having a volume V expands isothermally to a volume 2V and then adiabatically to volume 16V. The final pressure of the gas is dash and the gamma value is given 5 by 3. A. 64 times of P. B. 32 times of P. C. 1 by 64 times of P. D. 16 times of P. That's by knowing the relation between pressure and volume for adiabatic and isothermal process, that formula, by knowing the formula, you are able to find the solution for this 6th question. Let's move to last question. The coefficient of performance of a refrigerator is 5. The temperature inside freezer is minus 20 degrees Celsius. The temperature of the surroundings to which heat reject is dash. Option A 31 degrees Celsius. B option 41 degrees Celsius. C option 11 degrees Celsius. Last option 21 degrees Celsius. That is, by knowing the formula for coefficient of performance with respect to the temperature, you are able to find the solution for this question. Next session, we will solve the solution for this. Before that, you try to work out the problem and be ready. Thank you.